I want to pick up where we left off right here with the graphing real quick. Just a reminder, you go to y equals, type in your thing like 3x plus 4. The x button's this guy right here, xt theta n, and you go to graph. If it's not a good window for you, try zoom 6, which is zoom standard, and it should make a normal -10 to 10, -10 to 10 window. All right, now I want to also notice a couple other things. Look at the dots on this graph. Do you see how the slope is consistent along the graph? That's actually what makes a line a line. The slope is the steady rate of increase or decrease. So it goes up 3, right 1, up 3, right 1, up 3, right 1, up 3, right 1. It would work even for the middle. Like take the dot that's there's like an imaginary dot in between them. Go up 3, right 1. Hey, you're at the imaginary dot in between those two. Up 3, right 1. You're at the imaginary dot between those two, right? It's this consistent rate of increase or decrease. That's what slope is. Now it's easy to spot, and I'm going to make a little notes here. Note. Slope is the consistent, some could say steady, rate of increase or decrease. Here, I'll make it easier. The steady rate of increase or decrease for a line. Now you can see it visually. It can be seen visually in 3 ways. Now, what are those 3 ways? You can see it in the equation, right? So in the equation, you look at it, it's y equals 3x plus 4. That 3 right there, that number that's times the x, that's your slope. Okay, so that's how I see it in an equation. You could see it in the graph. That's what we were just doing. That's that, and I'm using this example that we had, but we went up 3, right, whoopsie, right 1, right? When you do that, because our slope was, I should be clear, the slope was 3 over 1, so we kept seeing up 3, right 1, up 3, right 1, up 3, right 1 as we moved along. And then there's the other thing. Oops, I just changed that to graphically. And I just wanted to say this equation is what they mean when they say algebraically, right? That means in an equation form, okay? So then there's one other way, and that's what we're getting to with this guy right here, and that's numerically. That means in a table. So in a table, you can spot it as well. Now, how do you spot it? Well, hold on. There we go. And again, I know it's probably tight on your paper. You might want to like squeeze this in the margins or something, or put it on another sheet. But you've got this table, right? And all these are the points. See those dots right there? I just made a table of them, right? Those same dots. So I said, look, as your x increases by 1, look what happened. X went up by 1, x went up by 1, x goes up by 1, and so on. Look what happens to your y. It went up by, at least I think I did this right. Oops, that was supposed to be -2. That's a problem. Okay, so it went up by 3. And then it goes up by 3 again. Then it goes up by 3 again. 4 plus 3 makes 7. 7 plus 3 makes 10, right? So you can see at right that as x goes up by 1, y goes up by 3. That was our example. That's what they're getting at in this box here. They say, look, if your slope is your slope, then what's going to happen is that every time your x increases by 1, whatever your value is, then your y will increase by whatever the slope is. See that? As the x variable, the independent variable, increases by 1, right? y1, well, because it's always 1, right? Your slope is always 3 over 1. Even if it's 4/3, you can say it's 4/3 over 1, right? So as x increases by 1, the y increases by m, right? The dependent variable changes by the slope m. That's what they're saying right here. As x goes up by 1, y goes up by m. They're getting at that same idea. Really, really important idea. So you can see it in the algebra. You knew the slope was 3 when you looked at it. You can see it graphically. You went up 3, right 1, up 3, right 1, up 3, right 1. But if you made a table instead, then you could still see it. As x goes up by 1, the y goes up by 3. Right? And that's what this little table up here is getting at, this little box. All right, now we're going to use that to help us figure out whether these equations are the equations of lines. Because if they are lines, then we should be seeing that pattern. Okay, so let's look. As x goes up by 1, x goes up by 1, the y drops by 7 for that one, which means 6, drops by 6 for that one, drops by 6 again, drops by 6 again, drops by 6 again. So set 1 is definitely a yes. It's a line. And in case you're interested, well, even if you're not, what's the slope and what's the intercept, right? So it should be y equals, now we said we were dropping 6, so it's minus 6 for your slope because you lose 6 every time your x goes up by 1, x plus, and while we're on the subject, the y-intercept is right here. The y-intercept is what happens when x is 0, so it's 73. There's your equation for that one. Take a moment and look at it. In fact, I'm going to put it in a different form here. Y equals negative 6x plus 63, I think it was, or is it 73? Oops, 73. 73. Right? Y73, that's the y-intercept right there. And then negative 6 because you drop 6, drop 6, drop 6 every time. Now what if they hadn't given you the 0? What if that hadn't been there? Right? Then what would you do? If that was missing, you could still figure it out because you'd say, okay, look, if I drop 6 every time, then what I really want to know is what's happening when x is 0, right? That would be my intercept. So you say, okay, down 6, down 6, down 6. Then to get up to this one, I would add 6, right, to go backwards, and that would get me 73. So even if they hadn't given that to you, you could still figure it out. Now what about set 2? Let's see, we add 5 for that one. Then we add 4 for that one. Then we add 5 again. Then we add 4. So that's not a line, right? Set 2 is not a line. But it's close, and you can tell it's close because the slopes are all very close, right? You'd say, okay, look, it went up by 4, it went up by 5, it went up by whatever, right? So it's getting close to the same amount, but it's not the same amount every time. All right, set 3. Okay, now set 3 is a little bit funky. So you'd say, okay, look, x goes up by 1, by 1, by 1, by 1. Does your y go up by the same amount every time? And the answer is kind of yeah. This is a special case, so let's make a note. Special case. This is a line. Here, let me make a note. So yes, it's a line. Now what kind of line is it? That's what's so special about it. It's y is equal to 2. It's a horizontal line. Because the slope is 0, right? You go up by 0 every time. See? Up by 0, up by 0, up by 0. The slope is 0, which we know means that it's a horizontal line. And that means it's a special case. So it is a line, but it's just not a diagonal line. So I better make a note. Special case. Those horizontal and vertical ones, this author in particular really likes those because they're special. They're kind of weird. So be on the eye for those. Right? But yes, this one's a line. Its slope is 0. All right, we're all done with that. Now, what about these ones? So hold on, I got to fill in some space here real quick. There, I had to move those just a little bit, otherwise I was going to run out of space. Okay, so set 2 is not a line, set 3 was a line, and now we're down here on this one. Okay, so we got to determine these are linear. See, it says they're flat up linear, no troubles. But what you got to do is you got to complete the table. All right, now if they're linear, that means that we could find their slope. Now this one in particular is easy to find because as x goes up by 1, the y went down by, let's see, 7, right? If you subtract. So then just subtract 7 again. 76 take away 7 is 69. Take away 7 is 62. Take away 7 is 55. Take away 7 is 48. And you're done. You filled in the holes. Everything's great. Oh, I better not do that color. It bleeds in too much. There we go. Okay, now what about the next one? Now that's a little trickier. I mean, you could figure it out. If it's a whole number answer, you could figure it out just by guessing and checking, right? So you could say, oh, let's try 1. 13 plus 1 is 14. 14 plus 1 is 15. 15 plus 1 is not 22, so that's no good. 13 plus 2 is 15. 15 plus 2 is 17. 17 plus 2 is not, that's no good, right? And you could keep fiddling around with it. As long as it's a whole number, if you trial, it's called trial and error. You try stuff out and see if you make a mistake. The other way to do it is just to flat out write out the equation for a slope. M is equal to y2 minus y1 over x2 minus x1. Now you know y2 because of the table. You can see that it's 22. So you can say, okay, that's 22, take away 13 over 4, take away 1. That is 9 over 3, which means my slope is 3. Right? Okay, so, and again, this one you could have gotten by guessing and checking, that's fine, but it doesn't hurt to know how to do it longhand if you have to, because if it's funky, if it's not like a whole number, this is the only way you got. So 13 plus 3 means 16. 16 plus 3 makes 19. 19 plus 3 makes 21. Yay, that's what we wanted. 22, I'm so sorry, 22. 22 plus 3 makes 25. 25 plus 3 makes 28. There we go. Got them done. Okay, now let's do the same thing with this other one. Okay, so by hand for that second set. Oh, goodness. All right, so what's our y2? That's 80, take away 90, over 28, take away 24. So that's negative 10 over 4, right? Which is negative 2.5, I think. Okay, so let's just do the decimal. That's easier. So then you say, okay, take away 2.5 gets me 87.5. Take away 2.5 makes 85. Take away 2.5 makes 82.5. Take away 2.5 makes 78.5. No, 77.5. What am I thinking? All good? So we filled in this one right here, and then all these ones in between. So do you see how the by hand method kind of helps you there if you find the slope first? Okay, let's move on to the next one, which is let X be the driving time in hours since a person fueled up the tank of their car. Let Y be the number of gallons in the person's tank. So assume that the equation is Y equals negative 3x plus 18. Describe the relationship between X and Y. So what I first did was I filled this in. So I said, okay, when 0 is X, then Y is 18. When it's 1, it's 15, and so on. So I filled that out. So I completed the table. Now, how much are they losing gas each hour? So you can see it's negative 3. You can see it in the equation, negative 3. You can see it in the table. You're dropping 3, dropping 3, dropping 3 every time. Okay? So 3 gallons per hour. Right? So you could say even losing because it's negative. On a side note, this tank holds about 18 gallons, right? Because that's the y-intercept. Right? Because it's plus 18. So they must be starting out at 18 gallons, and then they lose 3 gallons every hour. There's the algebra part of it, the negative 3x plus 18, and then there's the numerical part of it. And if you wanted, you could make a graph as well. All right, last but not least, we've got to find the equation, sketch the line and find it by hand. Okay, so what you do is you graph negative 4, 4, put it right there at negative 4, 4, and now you use the slope, up 1 over 2, put a dot, up 1 over 2, put a dot, and work your way along the graph that way. Like so, up 1 over 2, up 1 over 2, up 1 over 2, fill them all in, then connect the dots with a line, boom. And now you can see the y-intercept is 6, so you know that the equation must be y equals 1/2 x, because that's the slope, plus 6. And you're all done. And we are finished with this section. I'll meet you back here maybe for 1-5. See ya.